Welcome everybody. I'm Baring-Gould from the National Renewable Energy Laboratory, and welcome to this overview of the Competitiveness Improvement Project for 2021, because we're still in that for a couple more days. The idea of this workshop is to provide information about the Competitiveness Improvement Project, answer questions, bring people up to speed on the project and stuff going forwards. So thank you all for being here. As I said, we've set this up not in a presentation format, but in a kind of workshop dialogue format. So that means each of you control your own mute functions. So please, if you're not talking, make sure that you are muted. And then once we get to the Q&As, we'll try and raise hands and try to get into a little bit more of a dialogue around this using the Zoom platform. So without further ado, I'd like to introduce Brett Barker from the U.S. Department of Energy, the Wind Energy Technology Office, to give a little kind of brief comments and introductions to start us off. So, Brett.
All right, thanks, Ian. And thank you everyone for attending and for your interest in the Competitiveness Improvement Project, or as we call it at DOE and NREL, the CIP. And thank you to the NREL team that administers the CIP on behalf of DOE and continuously works to tailor the program to meet industry needs and increase the program's impact. The CIP is the Wind Energy Technology Office's flagship program for small and medium scale wind turbine technology development and testing. And I think its longevity is really a testament to the successes of your collaborative efforts. So thank you. So the CIP has helped the small and medium wind industry offer more compatible, capable, and cost-effective products, and has also been a driver of turbine testing to performance and safety standards, which is a key step towards commercialization and incentive program eligibility. By implementing the learnings of the large wind industry and through innovation, the next generation of small and medium wind technology is arriving. The current administration has offered a new vision for the energy system of the future, one which has the potential to greatly expand the use of renewable energy and distributed energy resources. The Wind Energy Technology Office sees the advancements achieved through the CIP as critical for ensuring that small and medium scale wind technologies can support achieving this vision. So please take advantage of this workshop to learn about the different facets of the CIP and associated technical resources, including but not limited to the topic areas, the evaluation criteria, available design tools, electrical and turbine standards, the contracting processes, available lab-based technical assistance, and expectations for deliverables and outreach. Finally, I ask you to take this opportunity to let us, DOE and NREL, know where the CIP can be improved or expanded upon. And really of particular interest in this regard, and there's dedicated time to this on the agenda, is to discuss the question, has CIP accomplished the goals and objectives it was designed to achieve? So we're approaching the 10th year of this annual solicitation, and I think that's an appropriate question to ask. And if it hasn't, what's left to do? And if it has, what's coming next? So more on that during Thursday's discussion. So in closing, I thank you again for your participation. Your contributions towards offering a new generation of small and medium scale wind technology will help realize the administration's decarbonization and energy equity objectives. And please take advantage of this opportunity to learn more about CIP and provide us with valued feedback on the program. So with that, Ian, as time permits here, I'm happy to answer a few questions if you want to go that route, or just keep it rolling.
Yeah, I would say if people had a couple of questions, we certainly have time for one or two. People want to just unmute and ask, go for it. There's not too many people jumping in. If not, we can go on.
This is Alex Kogan. I'm CEO of Hughes Technology Incorporated. Can you hear me?
Yes, we can. Go ahead.
Okay, I have a question. Since 2018, we are developing wind system with basic goal to be able to reach high extreme wind condition area. And we applied for CIP program back in 2020. And when we got reviews from reviewer, everybody likes our system, at least they said so. But question was stands, almost everybody asked question, where have you seen wind area with high wind velocity? Industry today, and what we are talking on this CIP program, is basically focused on EIC wind area, basically fourth and third group, with average wind speed 5.5 meter per second to 7.5 meter per second. And actually, when I'm reading survivability features of existing wind turbine, big and small, that basically most of these turbines can survive, let's say, some of them category 3 hurricane, but most of them category 1 hurricane. I met personally with CARICOM, Caribbean Committee, and they said, and I have this letter sent to me, they said that hurricane for them right now is not act of God, but basically everyday reality. And all of us saw basically what happened in Midwest last week. All right. Now, one more, I'm sorry, it's a long question, but it's basically it's coming to topics of this CIP. Question is that our system, what we develop, for example, I'm not trying to introduce this right now. It's engineeringly proof. It's most robust system in the industry, and it can survive Hurricane 5 wind. And our system has advantages in effectiveness of producing wind with wind velocity starting from 17 and higher. From about 14 to 70 meters per second, we are working almost same on effectiveness as any conventional wind turbine. With low wind speed from 5 meters per second, let's say, to 10 meters per second, we about 5–10% low than effectiveness of wind turbine. But in today's world, if we believe in climate change, extreme weather is with high and extreme wind is basically everyday reality. And there is, at least what I know, correct me if I'm wrong, there is no on the market any wind system, big and small, who can survive. Even survive, I'm not talking even to produce power.
Sorry, Alexander, is there a question here? I don't mean
yes,
to cut you off, but can we get to it?
Yes, question basically is, I will make one more note and after this question. Construction code in many regions, for example in Florida, require any structure to be able to withhold, let's say, category 5 hurricane. We are talking about 157 miles per hour higher. There is no wind turbine in the world today which can actually stand by and not be destroyed by this hurricane. My question, now it's question, why, because of world changes, why not to make one topic and basically to discuss and get maybe somebody, at least we have, but maybe somebody else has the system which can work and produce power and sustain high extreme wind conditions.
So
Okay.
to see if I can reflect the question back at you. Are you asking why there isn't a topic area targeting, we'll say, hurricane resistant turbine technology? Is that the question?
Yes, hurricane resistant, tornado resistant. I'm talking about at least high wind, because conventional wind turbine right now, you have to, let's say, with rated wind velocity 10, 12, or even 14 meters per second, they have to be stopped and turned with 24, 25 meters per second, and they will not survive even category 3 hurricane, as we saw, let's say, in Puerto Rico, when we saw. Yes.
Sir, I think we get your question, and you've been talking for 5 minutes. So your question is there value, and I think it's certainly an open question, of a high reliability or a high wind speed topical area within CIP. And I think that is certainly something that we could consider. Brett, please feel free to jump in.
Yeah, no, there's nothing preventing you from submitting a proposal targeting that type of technology development. The CIP is intentionally open and inclusive, and in my opinion, not really restrictive in the its design, so that it can accommodate proposals like this, or less conventional wind turbine concepts. And so I think your comment is well taken. And
yes,
I'm sorry, follow on with the proceedings here.
Yeah.
And maybe identify what makes sense from a topic area perspective.
I will tell you, I understand you, Brett, and thank you very much. This is what we tried. But when we got these reviews, major point
sorry,
was,
Alex, I got to cut you off here because there's a lot of other people on the call, and I'd encourage you to take this up directly with NREL and Ian. You have the opportunity to do to get a debrief following the submission of your proposal. So if you haven't done that, I encourage you to do that, and I suggest we move on here, Ian, too.
Yeah,
thank you very much.
And we'll touch on these things in a number of different ways. So your point is very well taken. And let's see if we touch on it in a couple of ways here over the course of the discussion. The only things I wanted to add to Brett's comments, which were great, so thank you for that, Brett, is that the goal of CIP is to be supportive of the industry, both in regards to the work that is done, but then also the development of the process and the development of the CIP process. So please kind of listen, take notes, ask questions, feel free to do that. And if we have to move them offline, we're more than happy to do that. We're here to make sure that this is supportive to the industry players. These presentations are being recorded and will be made available. And so don't worry too much about taking notes because we'll have them available to you. Please attend the sessions on Friday where we'll delve into some of the topical areas and have more time for discussion around each of the topical areas. So kind of ingest what you see over the next couple of days, but if you feel your technology fits in one or two of the topical areas, please attend those 2 sessions on Friday, and we'll talk about those really quickly. I do want to say that CIP is amazingly competitive, and I'll talk a little bit about that in a future presentation. And so we get way more presentations or solicitations than can be funded. And so it really takes a lot of time to develop a good CIP proposal and to hit all of the issues. And so really think about that over the next couple of days to decide whether you actually want to submit a CIP proposal, because it takes time and energy to do so. And you really have to have a technology that fits very well into the different topical areas to be able to be successful. Then finally, I just want to echo Brett's kind of final call there that we really look for the industry to provide input into how to improve CIP and improve the topical areas like we just had that comment about. And so if there are topical areas that we need to include or change, we're more than happy to do that.
Thank you.
So quickly moving on, Quickly, the agenda for the couple of days, there is an agenda on the website, so please download that and take a look. The sessions are running from 12 to 2:30 Mountain Standard Time each day. And then I've highlighted kind of the times here. We will try to take breaks and start the sessions after the break right on time, so that people can kind of pop in and pop out. We do have question and answer periods kind of sprinkled through the agenda to be able to cover those. And then we also have the session scheduled on Friday, where we really want people to have the opportunity to really dive into these topical areas. So if you really have specific questions about the topics, save those for Friday and join those calls. We don't expect everybody to sit through all 6 hours of that. We expect people to pop in for the ones that they are really feel are appropriate for their technology.
Thank you very much.
No, our pleasure. And we hope to have plenty of time for Q&A to talk through specific considerations on all of those. As I said at the top of the hour, please mute yourself unless you're asking a question, and then we'll do the same. Please post questions in the chat that you have, and we'll try and go through all of them. When you do ask a question, be sure to introduce yourself. We don't have an opportunity to be sitting in a conference room and chatting, which is one of the great things about these sessions in person, but let's do what we can to make it as communal as possible. And then also really try to be quick and to the point in your questions so that we can get to everybody. It's really important to note that all the responses to the questions are based on our best experience, but should not be considered as definite guidance in regards to any potential future solicitation. If you have questions when and if a solicitation is released, if you have questions specific to those solicitations, there is an opportunity to ask those in a formal way, and we will respond in a formal way. So we're talking here and trying to be as open as possible about CIP, but make sure that you really read the solicitation when and if it comes out. And if you have specific questions, you ask those around. And then, as I said, we're really sorry to not allow the cross-industry dialogue that we would have gotten in an in-person event. But please feel free to communicate with people that you see in the dialogue. So thanks everybody for kind of dropping notes in about who you are, what your company is, and how to contact you so that people can reach out. So just quickly as a notice, NREL did release a special notice on December 6th last week, stating that we intend to release an RFP for CIP early in 2022. So our intent is to do that. Once we cannot comment in any part of this solicitation, and I'm sure you've heard that inflection in my voice about future solicitations. We cannot talk about those, but what we can talk about, and so what we will focus on the information we cover over the next couple of days, is what past CIPs have done. And as we all know, past is a pretty good indication of the future, though it's certainly not guaranteed. And so we will do our best to cover the stuff that has been released in the 2021 CIP, and all of the comments that we provide are really in reference to what happened in the past. And then what happens in the future will be what happens in the future. And then once an RFP is released, then DOE and NREL are not able to talk about CIP at all. And so Brett and I have encouraged you to engage with us, with the whole team at NREL that will be introduced over the next couple of days, about any questions you have about kind of previous proposals or ideas that you have and whether it fits into CIP. Now is the time to have that dialogue kind of during this conversation over the next couple of days or until the RFP is released. But once the RFP is released, we cannot talk about the RFP. And so encourage you to engage with us sooner rather than later. If you have specific questions about the RFP process or want to be put on a list, please contact Kendall Jackson, and her email address is there. And then the CIP website is also a great place for information about CIP, past, present, and then when we make any announcements, we'll include that within CIP or on the CIP webpage. So there's my email address. And again, we'll try to move on quickly for kind of questions, but please don't hesitate to follow up via email if you have kind of more specific questions to your technology or anything of that nature. So I'll quickly.
Yes, Ian, the one
ahead.
other thing I'd add here is it might make sense to have people that have sort of company specific questions or otherwise to put them in the chat, and the team can respond, so that we're sticking to the agenda and stay on time.
Yep, no, that makes perfect sense. All right. So without further ado, unless anybody has any specific questions, I'll jive through kind of a quick overview of CIP. Again, apologies for folks that have seen this presentation before. There's a little bit of updating here, but a lot of it will be at least slightly repetitive. All right. So I think the challenge that that we have in front of us, we've talked about and everybody knows. The distributed wind industry is continuing to struggle to compete with lower cost distributed generation technologies, primarily photovoltaics, and a relatively limited consumer confidence in the product. And so CIP is really designed and was developed from the Wind Energy Technology Office and NREL to help offer competitive cost shared solicitation for manufacturers to optimize designs and to come up with products that can compete in the open market. And so we're really looking for, within the objectives of CIP, is technology that is lowering the levelized cost of distributed wind into the market, and so you're competitive. And to a degree, this gets back to the comment that we had earlier. Certainly, if you can demonstrate a competitive market price in specific markets, then you have a strong proposal. So in the case of an extreme wind speed technology that's hurricane resistant, if you can demonstrate a really strong market in the Caribbean, as an example, for your technology, and you can document that market, that will make a strong CIP proposal. If you just say, I have a high wind speed technology, but don't describe what the market is, well, then you have a really high cost technology, and that will compete in the regular market. And so it's hard for the reviewers to grade that well, because you're not demonstrating the market for which your technology is appropriate. And then the second point is increasing the number of certified turbines. So having low-cost turbines doesn't help if they're not certified and they fail after 3 weeks. And so this whole idea of low-cost technology that is certified for the marketplace is, to a degree, the holy grail of the CIP effort, working to help companies provide both of those. A product that is cost-effective in our current market space, whichever that market space you define it to be. So if your market space is rural Alaska, and you can demonstrate you can sell 1,000 turbines in rural Alaska at a price of X compared to the competitive technologies, then great. If your market is a farm in Kansas and you can demonstrate that you have a technology that will be certified, that can be certified, that competes with whatever the competition is in rural Kansas, then great. Those are the kind of projects that we're interested in. A certified turbine that costs 10 times the current market price for that location in rural Alaska or the Caribbean or that farm in Kansas, that doesn't help anybody. And so it might be a great idea and great technology, but it doesn't have a path to the market. And so these two things are really critical and weave through everything that we do within the CIP proposal, review, and implementation. As Brett said, we've done a number of solicitations over the years, and they're kind of demonstrated here. with subcontracts to 52 different subcontracts to 25 different companies, with $12 million out the door, leveraging about $6 million of additional private sector investment. So this is why we feel that CIP has been effective. A bunch of different companies, so we're not a kind of pigeonhole into one technology, and a number of these companies proposing multiple projects through the CIP effort to get to a final competitive product. And then we also have good geographic diversity around the country. It is also important to note, this last bullet here, that not all projects are implemented completely or successfully. So although CIP is competitive, we want to work with manufacturers to implement new technologies and new ideas into the market space. And that means that as you go through these projects, it's all in both of our interests, the companies, NREL's and DOE's interest, that if we get to a place where we determine that this product can't get to the market and can't be certified, that we identify that early in the process and then stop wasting your time, your money, and the taxpayer money in trying to implement something that we know is not going to be viable. So even though we're all working to make these same goals, if it turns out we can't, once we get into a project, it's best for all of us to realize that and stop instead of pursuing something that is not going to be worth pursuing. Again, as you can see, we've done 8 to date out of the 52 that we've let. And so the track record of all of you, the companies that are submitting CIP, as well as the work from our side, I think is largely successful, given the number of successful projects that are underway or have been completed. So the technical approach of CIP is kind of covered here. I've already mentioned that they're competitively selected and cost share. And so competitive, that means that to a degree you're competing against your brethren to propose the best idea. And then the cost share is part of government contracting, so we have to do that. But then it also means that you have skin in the game. And so you're putting your money in to match with our money to get to a final product. The idea is to do relatively short projects, and you can see that by the number of projects we funded with a number of companies. So we want you, and we'll dive into this much more over the next 3 days. We want you to be looking specifically at steps to innovation, and we don't expect that you start off on day one with everything lined up to the end product. And that's because, as we know, and as all of you know, that the technology innovation is not a one and done idea. And so we want to help you move up the ladder, the development chain of your technology. And that means you do a project, we assess it, we understand it, you get a better understanding of, are you going to be competitive? Can you get to certification? And then we keep reevaluating that. We, being you and us, reevaluate that on an ongoing basis. What that means is that when you get to the end of a certified product, you and we are really guaranteed that you do have a product that can be competitive in the market space that you've defined. And that, again, is our ultimate goal, is a competitive product at the end. The fact that companies have to submit for CIPs multiple times to get to that is probably a pain, but it also helps ensure that those final goals of a cost-effective technology that's been certified and can play a role in the market is achieved. And we do that by going through these checks repeatedly to make sure that all of us agree, you and we agree, that you're on that pathway. Generally speaking, we're focused on technology that's in the higher technology readiness level. So CIP is not a basic R&D effort. We do prototype development. And so that's one of the categories, and we'll talk about that quickly. So we do prototype development, but you have to have a really solid product at the prototype level. We're not doing basic R&D within CIP. That's not the goal. And so if you have a crazy idea that might be wonderful and might work, but it is R&D, There are other things like the SBIRs and other avenues to pursue, and CIP is not one of those. So we don't want you wasting your time pursuing that. We are technology, configuration, component, and application neutral. So, and you'll see that if you look over the previous CIP awards, whether you're horizontal or vertical, doesn't matter. If you have aerial turbines and want to propose those, that's great. Encourage them more than ever. The key is, though, we're not doing basic R&D, and you have to demonstrate that you have a product that can reach commercial viability in a certified fashion. So you have to demonstrate those. So any technology, any concept that gets to that, and you can demonstrate to us that you're on a path to that, is what we're looking for. I've already talked about the kind of the solicitations, sustained solicitations, and as we've seen, we've done 9 of them. Brett mentioned the kind of the dialogue on Thursday about what happens with CIP going forwards. But the idea is to do this every year so that technology can move up that process. We certainly, as I mentioned, work with awardees to end contracts if it's determined that the scope is not achievable. And then we'll talk about this later in the day or tomorrow. But NREL and the other laboratories do provide technical assistance and technical support to you to make these projects go forwards. So here's an example of this kind of pathway using Berge Wind Power, which is one of the great companies and a great partner. But you can see that the Berge Wind Power has gone through this kind of CIP process a number of times to go from the technology that they had in 2012 to the technology that they have in 2021 and going into 2022. And it's not included in this graph or in this chart, but they recently received a new CIP award from last year looking at how to optimize the cost of their highest cost component, being the alternator. And so the idea for CIP is for companies to kind of move through this process of either innovating new technology or taking an old technology and looking to see what can be done to make it cost effective and certified. And in this case, Berge Wind Power has been successful in cutting the cost of the technology by over 50%. And continues to work on that because they see that as being critical to being able to compete in this market space. So the topics that we have in CIP, and in the next session, we'll dive into these in much more detail. And then, as I said, on Friday, we'll dive into it in even more detail, are covered here. So as you can see, we really cover the breadth of this kind of design process, from this kind of prototype or pre-prototype development, getting a concept together that you've done a lot of homework on, but you're not sure, or you need help with getting it to the point of a prototype unit. Prototype manufacturing and installation, so that if you've got a prototype design but need help manufacturing it and installing it to kind of put it through its paces. If you're a little bit farther along and want to test the prototype, we'll help cover the costs of the installation and the prototype testing. Optimizing the whole system. So in this case, you have a product that might be on the market now, but is not economically viable. How do you optimize that system to lower the cost of the technology so that it will, or lower the cost or improve the performance of the technology, so in the end it will be viable? Or if you want to add new capabilities to your product, and that requires optimizing a number of components like the whole power chain or incorporating storage or something of that nature to give you additional value, then you're optimizing a bunch of systems. Component innovation, and that is looking at taking a single component, the blades of the turbine, the power electronics, or something of that nature, and again, lowering the cost or increasing the performance to lower the life cycle cost of the product. Then we have 2 topical areas in this certification space, one for small wind turbines, and then the other one for type certification for the larger turbines, and then a manufacturing process innovation and improvement. So if you've got a good technology, but you want to look at tooling or things like that to, again, lower the cost, improve the reliability, things of that nature. We have a topic in that area. So again, you can see that we try to not only have different topical areas where different companies can come in depending on where you are in your development, but then also a process that you can go through to over a number of years, engage CIP on a number of occasions to optimize your system, improve a component, certify the turbine, and then support the manufacturing of that turbine as it gets into the marketplace. So a number of different ways that you can engage. To make it really clear that over the past, not every topical area has been offered. And so be conscious of that. And then we're also, as Brett stated in the beginning, we're always looking to make sure that we're covering new or kind of gaps in this market space. And so the prototype manufacturing and installation was introduced last year. And if there are different topical areas, like we've talked about a high reliability turbine or something of that nature, if the industry feels that there is a real need in that market space, then we're interested in hearing. If you're unsure, as I've said previously, if you're unsure of where you are in the development place, please reach out and have a conversation. The last thing we want you to do is to spend the time to develop a CIP proposal for take something easy, small turbine certification, and find out your turbine actually fits in type certification. And so you submitted a proposal into the wrong category and we can't fund it. And so we want to avoid those kind of mistakes and make sure that you're submitting where your technology is. And we're more than happy to help you with that. Some examples of projects that have been within the scope, and I'll go through this quickly because I know we're running out of time. Pre-prototype turbine assessments. You have a great idea, you've worked on it, you've put it in a wind tunnel, you have done a bunch of finite element analysis, you know you have a product, you've done the economics, everything works, but you haven't done the detailed engineering work around developing your first real prototype that you plan to put out on a tower someplace. Certainly something that we're happy to work with you in submitting a proposal for. Overall optimization of how you can look at components, that certainly fits. The new components such as inverters, blades, towers to reduce costs. Certainly looking across all turbine sizes and turbine topologies. Non-turbine components. So we funded foundations or new applications of turbines, so deployable turbines and things of that nature, certainly applicable. And then all sorts of turbine testing work is certainly within the scope of CIP. Stuff that is not within the scope of CIP is this kind of basic R&D. So you've had to have done your homework to make sure that what you are doing, again, can be certified and can compete in the market once you get there. And if you can't demonstrate that, a cost of energy of below 10 cents a kilowatt hour, if you're planning on installing your turbine in Kansas, then you're wasting your time in developing proposals. Certainly, let's see, if all the technical information that you have is a website or a video that says your turbine looks good and works great, you're not far enough along in the development process to get past the engineering reviews. Standalone components that are not partnered with a turbine manufacturer. So you have an absolutely great new blade design that you think is perfect and will increase the performance by 50%. You've done all the engineering, you're convinced that it will work, but you don't have a turbine manufacturer that will work with you to implement that and will support your project. Again, you don't have a path to market. And so you must be paired with at least one turbine vendor who is willing to use your technology to implement it, and that's critical. Turbines greater than 1,000 meters swept area. So again, this is focused on distributed wind technology, and so we have that limit. You have to be a U.S. entity to be able to do this. Now you can certainly partner with foreign companies, but you have to demonstrate an impact on the U.S. market. And so you have to be installing turbines in the United States, but you do have to be a US entity to be able to take advantage of this effort. We don't want people proposing to multiple topical areas. And if you have submitted a proposal for the same technology into 3 topical areas, well, then it's a clear indication to us you don't know where you are in the development chain. And that shows probably more poorly on your technical design than anything else. So understand where you are in this development process. Talk to us to make sure that we agree. And then, of course, we can't control where you submit. But if you're submitting for 4 different things on the same technology, that's going to be a problem. And then if you submit something and you don't match, then that's clearly an issue. Addressing challenges in project scope. So we have, to a degree, our hands tied in regards to if you submit a proposal and you're awarded that proposal, how we can change. Now, some things we can do relatively easy, changes in timing, different approaches once you get into it, all of that is fine. Shifting between vendors, if you have them, again, that's something easy to do. Project schedule is easy to do. If you're trying to go in as a small wind turbine certification, but then you end up needing to do a type certification, that's not something we can address, and we're going to have to end the contract. If you have a primary vendor or part of your team that you decide not to use, that's a problem, because we graded your proposal on the team that you told us you were going to use. And if now your whole team changes, then what you submitted is no longer valid, and that becomes larger a problem. If you come in and want to change the budget of your project because something changes, again, you submitted a proposal to us based on specific economics. And if those economics change halfway through the project, then that's going to be harder for us to deal with. Because again, we selected you based on a whole bunch of other, compared to a whole bunch of other technologies or a bunch of other proposals, and we have to honor those. So we'll get into criteria specific to each of the proposals or topical areas on Friday, but here's some kind of examples of different ones for the component innovation and a certification testing. But you can clearly see here these kind of the thinking behind. You have to have a solid product, you have to have it be economic and have impact in the US market, has to be certified, and you have to have a great team, a good team, to be able to bring that concept to the market space. And all of the CIP topical areas have slightly different criteria, but they all follow this same general logic of good technology that you understand, ability to impact the market by having a competitive project or product, sorry, being able to be certified eventually in that marketplace, and then again you have a team. If you do not address some of the criteria, you will get fewer points and you will not be successful. And I'll get to that in a second. We also add a number of program factors to the final score, and historically this has been about 5% of the score. But it's the things that are covered here. So manufacturer diversity, system configurations, topic diversity. And so you'll see if you look back at previous awards, obviously we're not going to give tons of awards, 3 or 4 awards to a same manufacturer if they submit different proposals for different things. So we do apply these program factors to make sure that we're covering the bases. And as I have said a couple of times, CIP is very competitive. And here gives a couple of numbers around that. In 2021, we received 34 proposals requesting over $7 million of total funding. Of those, 22 of them received a passing score. Okay, and that means you answered all of the questions fine. None of them were stellar, or maybe some of them were stellar responses, but you addressed all of the criteria within the RFP and did so reasonably. Of those 22, only 12 were really graded in the competitive range, and that's the kind of the 7 out of 10. So a score of C or above, which means you went above just the basic criteria within the RFP that I talked about earlier. Of those 12, only 8 were selected for award based on the funding that we had available. And so you're going from 34 to 8, which is not bad odds, but if you don't talk about your team, or you only put the PI in there as the team, you're not going to get great scores, and you're not going to be in that top 8. Okay, so you really have to understand the proposal, or the request for a proposal. You really have to, your proposal has to cover all of the bases, and do so exceptionally to be able to become that 8 out of the 34, or whatever number that we get. So we certainly encourage and want to help you in putting together strong proposals, and we'll do whatever we can to help you in that process prior to when the RFP is released. But you really have to do that if you want to be successful. And if you can't do that, then don't even bother wasting your time in applying to CIP, because you won't be successful, and no one wants that. So some general kind of consideration and recommendations. If you're making incredible claims, that's great. Please do so, but provide really strong evidence to back it up. The reviewers of the CI proposals provide over 150 years of wind energy development experience. And so
I see other people moving. I think Ian might have gotten frozen.
Oh, thank you, Heather. I was wondering. I'm
Hi,
so
Brent.
self-conscious about my internet connection.
Well,
Like,
I saw people moving on their cameras, so it's not me. Oh, we just lost Ian totally.
I can hear you guys.
okay, thank you, Rob.
Can you jump in, Brent?
Sure. Yeah, you almost made it to the end.
Nice.
Hello, everyone. Sorry, Ian was consumed by the internet problems, which happens. But we just got a lot of good information from Ian. So I think he almost made it to the end of his presentation. So let me look at the chat. Yeah, Tim says we lost Ian. Yeah, what a shame. It's okay, but he almost made it. And it's time to go into the next session anyway. So I think we'll go ahead and do that. So I'm going to share my screen. And talk about these topic areas a little more. All right, well, thanks everyone for coming today. I'm Brent Summerville with NREL. Thanks to Ian, Baring-Gould, and Brett for kicking it off. As you can see, Ian is a wealth of knowledge. He's been here forever, and is a great resource. So as he said, reach out with any questions anytime. And I do see a few questions in the chat, and we will get to those. Maybe some of you know me. I see some familiar faces out there and some new ones. I was a manufacturing engineer for a while, and then I did small wind testing on Beach Mountain here in North Carolina, where I work out of. And then I certified small wind turbines with the Small Wind Certification Council, and then taught sustainable technology, including wind energy, at Appalachian State University. And now I'm at NREL. I've been here over a year now, so I think I'm not allowed to say I'm the new guy anymore. But I'm happy to be here. I've always admired the work coming out of the Wind Energy Technology Office and NREL, so I'm glad to be part of the team. We're going to go through each of these potential topic areas in a potential 2022 solicitation with a little more information. And then again, on Friday, we'll go into even more depth on these individual sessions. Now, I looked back at some historical documents, and in 2012, when this program kicked off, there were three topic areas. Let's see if I can remember how to use Zoom. Give me a second. Seems like there's another window somewhere. Anyway, the three topic areas in 2012 were component innovation, manufacturing process improvements, and certification testing, which we now call small wind turbine testing and certification. And there were awards for two of those topic areas: component innovation and manufacturing process innovation. So as you can see, over the evolution of this program, NREL and DOE have added more topic areas to try to accommodate the needs of the industry and advanced technology. Here we have a picture of an active project in Pampa, Texas. We're looking at a 20 kilowatt QED wind power turbine that's using some of this CIP funding on certification. This session will also give you an introduction to a few more engineers at NREL that work on the CIP team. So that'll be good. I'll go first. Oh yeah, more reminders. Topics provided in previous rounds of CIP should not be considered indicative of what will be offered in any potential future rounds, but we talk about what we know, which is the past. Views expressed or included in this presentation are supportive of historical CIP solicitations and may not represent future potential solicitation. Check the specific request for proposal, RFP, topical areas and language when it becomes available, if and when, specifically for funding levels and cost share requirements. Funding levels and cost share are limits, not requirements, so design proposals appropriately. And there's a 2-bladed Carter, 300. So first, and you'll get a sense there's a progression here, but you certainly you're not expected to go through topic area 1 through the final certification. You jump in where best fits your status. But prototype design development, the scope of work for this particular topic area focuses on the completion of a detailed design. It means you've got a good start. The completion of analysis and/or testing of a beta prototype turbine or component to reach readiness for the development of a production prototype. So you have a pretty good design, but you want to refine your design to be a prototype. Now I'm going to borrow a little language from our friend Robert Preuss. You probably saw him here last year, but he's now retired, and you'll see him in the audience as a consultant that can help with proposals and design reviews. Hey, Robert. This topic area gives you the ability to take your design concept and refine it from a preliminary design to a production design. Manufacturability is a huge one. Spending a decade as a manufacturing engineer, you want to think about and involve manufacturing savvy individuals in the design process, so that when you get to manufacturing, you don't have these huge issues of you've got to redesign this so we can make it. You have more fun issues like statistical process control and quality control. You may refine the structure completely from what you thought it should look like, but after the design review and the evolution, it may look completely different. And on performance, you may have a lot of uncertainty in the performance, and this process can reduce the uncertainty, and it can also increase the performance of your design. Cost engineering of the turbine system is part of this refinement. Installation and operations and maintenance procedures can be clarified, improved, and documented. Supply channels or the supply chain can be developed and confirmed. And boy, I know that is a big issue right now and everywhere. And then testing of components to resolve uncertainties is another opportunity to refine your preliminary design. The result after the project is you're ready to build a prototype. Building is not part of the funding, but at the end, you have a design that's ready to build. The design review, or this topic area has a design review, which is a go, no-go decision. So there's several topic areas that have this, and it happens pretty early in the process. You have a design review with NREL to go over the design details, and it's pretty similar to a certification design review because we know that's your ultimate future. So you should be looking at the standards already and designing to be certified, even though you're pretty early on in the evolution of the product. Primarily, the design review is to confirm, not guarantee that the design is likely to be successful and that the claims in the proposal are justified. We'll review the subcontractor's testing and analysis to confirm performance and cost claims are reasonable, although some uncertainty at this stage is expected. So if you get the go decision, you do have ample opportunity to remedy errors and shortcomings in the design. So you'll have a report of issues to work on if you're if the team decides to go forward with the project. Unconventional designs come into this topic area, and working at the university and especially now at NREL, we see a lot of ideas. It's like small wind is the tinkerer's dream. I mean, it's at a scale where you could build it in your garage and it's very exciting, but an unconventional design is hard to define, but we know, you know what I'm talking about. They're often difficult to evaluate. Maybe they don't fit the requirements of the standards very well, but it's an opportunity, if it looks promising, to get a deep review with technical engineers. But it doesn't mean that your idea that you have with no physical testing or physics-based analysis will be seriously considered. As Ian said, it should be pretty well developed. Previous awards to unconventional designs have had some significant testing and analysis already done. And looking back at the history, there have been some no-go, at least one no-go decision in this category. The award amount is up to $200,000, and the minimum price participation is 20%. And here the example photo is from ducted wind turbines in the state of New York. I think a few of you are in the audience. And so that's prototype design development, our first topic area. And the next one will be described by Scott Dana with NREL.
Hello.
Hello.
Can you hear me? Okay.
Yeah.
Get my camera going. Yep. So as mentioned, we'll move on to the next topic area. This one might seem a little bit new. It was added to the last round. So those of you that maybe stepped away or were in between contracts with CIP or other organizations may be new to this one. And here we're talking about covering manufacturing and installation of the turbine only. Funding for testing would be out of scope for this award type. And installation is actually somewhat optional. It could just be for the manufacture of your machine. And this really is to allow for a little more flexibility and opportunity depending on where you are at in the development of your turbine design. It's to really support advancement of the next step, which would be prototype testing of the machine. So if the design is ready and the components and materials have been identified and characterized, and it's really the cost to, to put it all together to manufacture and assemble, this is an award type that would probably work out well if that's the stage you're at. The value, it does, it varies, unlike some of the other contracts, which maybe have a hard cap. This one actually varies based on peak power of the turbine design. There is a cap of 300K for the manufacturing costs. But for example, if you are a 50 kilowatt turbine design, you would actually cap out at 200K, 150 for the $3 per watt, and then the additional 50K on top of that. And it's kind of a similar formulation for installation as well, although in this instance, it's the $1 per watt of peak power. And then there is a 20K adder if you're under the 100K cap. So again, for like a 100K machine, you would max out at 100K in funding, and then for the let's say kilowatt turbine design, you'd cap out at 70K. The price participation is a little bit higher for this group, as well as the other manufacturing topic area. Here it is a minimum 50%. And like I mentioned, this was added recently, so it might seem a little new. Another intent of this award type is to kind of learn about the manufacturing process at this stage, and with the hope that it will lead to some improvements when things advance to maybe a production type run. Yep, that's it. Do you want to click me on to the next one there?
Yeah, sure. Thank you, Scott.
I think
there you go.
I do. Okay. So next topic area here is prototype installation testing. Pretty self-explanatory. We're trying to cover costs for actual installation of the turbine. In this case, it would not include any type of manufacturing. The idea is that the turbine is there, all the components are there, and it's ready for install at hopefully a test site that is suitable for kind of running through a lot of the different design load cases to really vet the product for commercial readiness. And here there is a maximum award amount, and it is $250,000. The minimum price participation is 20%.
Okay, thank you, Scott.
That's all I got.
Thank you. Let's see what's next. All right, Ian says he's on the phone and he will do this.
Oh, man.
Ian, are you with us? I'm not here. We're not hearing you, Ian. Let's see, I can't see the participant list very well. Boom. Yeah, Ian, I don't see you. So we're gonna keep going here with component innovation. And if you do successfully join, then just chime in. So component innovation, if you remember, this is an original topic area, and the scope of work for this topic area shall focus on significant upgrading and certification as appropriate of a specific turbine component of an existing turbine design, leading to lower costs and or higher energy production. So you're focusing on a component. Needs to be aligned with a specific turbine, but could be applied to multiple turbine platforms. So I can't see it and don't recall the details, but this may apply to the ARE telecom question in the chat. which I think was shown in that last example with the Xflow Vought. Component level certification costs can be included, such as the certification of that Intergrid inverter right there, but not if it requires a full recertification of the product. So check with your certification org. Right, so there may be opportunity to certify a component, not the whole turbine, but we'll have to check the details with that. The development of new applications are applicable, such as the Berge Wind Power deployable turbine concept. So that DARPS system from Berge with 2 XL15s in a deployable 40-foot container sized shape was through this component innovation topic area. And CI award amount maximum $400,000 with a 20% minimum price participation. And the example there is Intergrid's IG25, a new wind energy small wind inverter. And we're going to segue right into the next one, which is very similar. And Ian says he's back on the phone. Ian, did you want to say anything more about component innovation?
Can you hear me?
Yeah.
Great.
Yes.
Sorry, everybody, for this, typical
Okay.
life here. So the distinction between component innovation and system optimization, and thanks, Brent, for stepping in here.
Sure.
Component innovation is really focused on a single component of your system. And so that's blades or towers or something, as I kind of talked about before. The system optimization is really looking at combinations of systems that have to be redesigned to allow you to either provide new capability or to lower the total cost. And so there's kind of fuzzy space in between the two of them. But conceptually, if you want to do something that impacts multiple systems, you want to redesign your powertrain, you want to redesign the whole rotor with new kind of new capabilities, maybe pitch or something of that nature, then you probably fall more into the system optimization. Or if you have a product that's on the market now that you need to really take back to bare bones to understand how you can increase the performance or lower the cost of the whole system, then you really fit into that system optimization. If you have a single component that obviously affects other components, but it's really focused on a new tower, a new blade set, a new power converter, then you're in that component innovation. And again, come and talk to us if you have any questions and you're not quite sure where you fit into those categories. So thanks again, Brent, for picking it up, but that's it. And we'll talk more about these on Friday.
All right, great. Thanks, Ian. Oh, it's me. Next topic area is small. Let me turn my camera on. There's my face. Small turbine testing and certification. If you recall, one of the main objectives of CIP is to add more certified turbines. And my experience in certification is mainly with the now ICC owned Small Wind Certification Council, but that was propped up by the Department of Energy, because back in 2009, this industry said, you know what, there's not a lot of options for certifying our small wind gear. You can kind of follow suit with large wind, but it was gold plated, very expensive. And so a decade ago, we got our own standard, we got our own certification body, and there's a lot of interest in certification, and we've come a long way. We've gotten really mature in the certification world in small wind. This topic area is focused on certification of a wind turbine to a small wind turbine standard such as IEC, International Electrotechnical Commission 61400-2, which is an international small wind turbine certification, or a standard like what is just inches away from coming out, ANSI ACP, as developed by American Clean Power Association 101.-1. Previously, that would have been the AWEA small wind turbine standard, but it's a new version is coming out very soon. The work in this topic area can also include listing of the turbine or a component such as the generator or the inverter to the applicable standards such as UL 6142. Or only listing if the turbine is an already certified turbine. So maybe you have a certified turbine, you just want to list it to UL 6142. You can do that. The award amount is maximum $190,000 for the turbine certification. And you'll learn more about the 3 design methods, but if there are load measurements to be performed as part of certification, then there's an extra $80,000 to help cover that more expensive route. $80,000 available additional for turbine listing to UL standard 6142, or $200,000 for listing of the inverter. And with the minimum price participation of 20%. So a couple examples there. The Berge XL15 is certified to the AWEA standard, AWEA 9.1, and working on listing to UL 6142. The QED is working on both, all using some portion of CIP funding. And the certification world is volatile. I don't know. The amount of certified turbines has gone up and down through the years. Basically, it's because certification is an annual or a thing you must renew. And so some companies became certified. They targeted other markets and maybe they let their AWEA certification lapse. Currently, I just checked this morning, we've got the SD 6 kilowatt from SD Wind on the SWCC list, the Hivot DS3000 vertical axis turbine, the Berge XL10 and 15, the Kestrel 3 kilowatt, and we see QEDs on there as being in process. So yeah, that's it on certification. There's a lot going on here. We'll talk more about the new standard on tomorrow, opening session tomorrow, the new ANSI ACP 101-1. We'll talk more about the listing standards like the UL 6142 next after the break. And so stay tuned on that. Okay, and now we'll hear from Jeroen on type certification.
All right, thank you, Brent. So this category, and I assume you can hear me.
Yeah.
Okay, perfect. This category really is for turbine certification for turbine sizes that exceed the standards that Brent listed. So in the past, with the -2, the IEC 614-2 and a AWEA 9.1, or even SWT-1, those standards were limited up to 200 meters squared, which traditionally was about 80 kilowatts. With the ACP 101-1 coming into place, that scope is then going to increase to 150 kilowatts peak power. And so less turbines will likely fit into this topical area. But so you might consider this area 1 if you don't fit in either one of those descriptions, but also you could pick this category if you do fit in the ACP, but you're aiming for an international certification. So if you still exceed the -2, 200 meters squared, but you would still fit in ACP, but you're aiming for certification for multiple countries around the world, this would be the topic area because it gives you a certificate that's more internationally focused. Certification here does include things like load validation through measurements. It does include fatigue and static blade testing, and thus costs here are higher. That's why you also see the award amount higher. In the past, as Ian said, we've had a 1,000 square meter rotor swept area limit on this solicitation. I think we've all seen specific power decreasing over time, meaning that larger and larger rotors are being put on the same size turbines. And so this would be a great forum to get feedback from industry on whether that 1,000 square meters is still the right limit for distributed wind. We can't promise we can increase it, but right, without your input, we wouldn't have any incentive to change it either. Traditionally, 1,000 square meter rotor swept area is about a 35 meter rotor diameter, which traditionally would have been really medium to utility scale, and of course now becomes more and more distributed wind. The end goal, of course, of this topical area is to end up with a certified turbine. There are 2 go, no goes in this topic area. We'll talk about that a little bit more on Friday, but the first one is after the design evaluation basis. So to make sure that it's clear what we're certifying to what standards, and make sure that we can get that very clearly defined. And then the second one is after the design evaluation. This is a good point to kind of put that go, no go, because if out of the analytical design evaluation, it shows that the turbine cannot be certified, it would not be a good idea to spend all the funding on the expensive testing. With that, I think that's it for this area. Yeah, feedback always welcome. Back to you, or on to Dave. Dave.
Yep. Thank you, Jeroen.
All right. Thank you, Jeroen. Can someone confirm if my voice is coming through?
Yep, loud and clear.
Excellent. Well, I hope it keeps up. So last but not least is our manufacturing process innovation topic area from past solicitations. So starting with the first word there, manufacturing. So that's the focus of this topic area. And I think that's important to highlight because this is not the topic area if you have a concept for a prototype and you're looking for a way to build that prototype. This is for turbines that are, if you're already in production and looking for ways to improve the manufacturing of it. So that's the scope here. The intent here is that the applicant would select a baseline wind turbine or component to make some type of manufacturing improvement to. These types of improvements could be tooling, could be manufacturing equipment. A lot of possibilities on what that improvement could be. What else? So this topic area should be consistent with certification. So if the turbine or component going into it may already be certified. Some of the costs associated with this topic area can be used to recertify that component. But if a full system certification is required as a result of this, then there may be outside the scope of what this manufacturing process improvement would cover. Yeah, a lot of possibilities here. And with the maximum award amount of 500K and the minimum price participation of 50%, just to clarify what that would mean if you were to request a 500K award, you would need to put in 500K minimum of price participation. That 50% is based on the overall total amount of the project. So, and the intent there, part of the reason for that 50% is if you had things like tooling or manufacturing equipment, things that are, you're purchasing hardware, that would likely be used with your your cost share that you're providing for this subcontract, and not using the funds from NREL DOE for that equipment. So we don't have to have equipment ownership issues to work out. So that's the manufacturing process innovation, and we'll be talking more about this on Friday.
Excellent. Thank you, Dave. And thanks for clarifying on that price participation amount. That was helpful. Okay. One more. Boy, we must think you guys need reminders. We'll talk about it more on Friday. Just come into the ones of interest. And on those Friday sessions, we'll start on the hour, even if we get, ahead. So thank you very much for that. Now, we have a planned break in 7 minutes. So I thought maybe we could address these two very similar questions. Ian's here and he can answer questions, but he can't see them. So let me try to articulate them. One is from ARE Telecom, and they manufacture towers and assembled foundations like we saw in the X-Flow example. And ARE understands that they need to have a wind turbine company as a partner. ARE Telecom is a US company, but does their wind turbine company partner have to be a US company in order to apply to the CIP? Anybody know the answer to that? And it's possible we don't know. We have to huddle with contracting on some things like that. And while you're cogitating on that one or trying to get back, Luis asked a similar question. They are a foreign company. They don't have a physical prototype yet. Would we be eligible for CIP funding even if we, at this point, do not have an established US-based entity yet? Right. Well, I think Ian said in the intro that the subcontractor must be a US entity, so that needs to be established. But this is a great question. These questions around utilization of CIP funds for companies that aren't squarely based in the US is complicated, but it happens, and there's precedents in a few different scenarios. And it's as Robert said, said to me, it's a good time to remind you that all these responses, that if we get any, are based on past solicitations. Things may change in the future. And so, yeah, I don't hear any answers yet, but I hear
Brent,
something.
Brent, can you hear me?
Yeah.
Brent, you can hear me?
Yes, sir.
Oh, great. Good. Sorry for all of this. Service is out until mid-afternoon.
Oh boy.
Okay. So the answer to the first one, to ARE Telecoms, is yes. You do not. The turbine manufacturer can be an international manufacturer, and you're a U.S. company, so we can contract with you, and you can partner with a foreign firm. A foreign manufacturer. Now, the key is that you have to demonstrate impact in the U.S. market. And so that's both from a cost reduction standpoint, and that you are planning on deploying those turbines from that foreign manufacturer into the U.S. so that there's a return on investment from the U.S. taxpayer. Now, certainly, if you can articulate both the deployment of the turbines, and so there's person hours in doing that and economic viability here, but then also the fact that you're manufacturing your foundations here and the components for your foundations here, again, demonstrating U.S. impact of the investment of CIP dollars. And then clearly, if the company is planning, and again, planning is a key term, but if there is a market here, they would start manufacturing parts of their turbine in addition to the foundation, towers, et cetera. If you can demonstrate that that is what the plan is, and what partners they would identify here in the US to help build those components, then you're demonstrating more impact here in the US market. We certainly know from work that Pacific Northwest National Laboratory has done that the turbine itself is less than typically 50% of the cost of deploying a turbine here in the United States. And so even if the turbine is manufactured in a foreign country, if it's being deployed here, you can demonstrate a market here and a path to the market for that foreign produced turbine, then you're having US market impact. So that is certainly fine. The second question, from the second company, you have to have a U.S. corporate entity because we cannot contract with a foreign entity, and so you have to have that that U.S. presence here. If you're even
Ian. You there, guys?
Yeah, Luis and Ian was answering. Could you not hear?
Yeah. Luis, do you want to restate your question? Or can you hear me?
Yeah, we can hear you.
Okay, good.
So Luis, the company does have to have a U.S. market presence. Again, you can fit into any of these topical areas, and it certainly sounds like your technology would fit into that. If I'm remembering correctly, the prototype development area or the prototype manufacturing and installation. To the extent possible, U.S. taxpayer funds, so the NREL portion of the grant should be spent in the United States. Again, it's U.S. Taxpayer dollars, and so there's interest in having that spent here. If there is justification for why that can't happen, you've looked at U.S. companies, and there are no U.S. companies that will make the device that you're talking about, or something of that nature. If you can really justify that, then it's possible to spend money outside of the U.S. For work. Again, you have to be a U.S. company, but you could be a U.S. company that then pays for work to be done in Germany, as an example. But we want to make sure that you have checked to make sure that there's not a U.S. company that could perform those services for you. But if you can demonstrate that, then that is acceptable.
Yeah, Ian, our goal is to be based out of the US and exploit the technology in the US. And for that, we're in the process of creating a legal entity in the US. So, again, we were talking about foreign technology that would be applied in the US. And what it seems for your response is that if we establish a US entity that would, pay taxes and do whatever it needs to be done in the US, then we can qualify for this kind of, for the CPI, at least on that portion. But we're in the process of creating the legal entity that would host all our patents and all our technical documentation in the US. And we want to exploit the technology in the US.
Okay, that's perfectly fine. And to be clear, the company doesn't have to exist when you submit the proposal, but the company has to exist when we sign the contract, or else we can't sign it. And so if you're not incorporated in the US by the time the proposals go in, just document that in your proposal that you're in the process, and the goal will be to have it done by X date.
It's very easy. It's very easy. We're in the process of doing so, and it's going to be a Texas-based company, so it's very easy to do that in the US. So we don't have a problem with that. Even though it will have people from outside the US, the company is going to be US-based. So that's something good for us, because we're interested in applying. Just our other question is there, and it's about the I think that for us only applies the prototype, because we have everything. We have the patents, but we still don't have a prototype, a physical one. Everything is in computer and in all the formulas have been developed, but there's no wind tunnel. we're still in the process of trying to do the proof of concept with a physical model. And I don't know if we're still too early, but not sure.
Yeah, so again, trying to keep this general. It doesn't sound like you're too early. You could fit in one of the couple of categories. Let's have a discussion at some point after the holidays about where, based on where your specific technology is, which one might be the most appropriate.
Perfect. So we'll stay on your recommendation is for us to stay in the complete boot camp, right?
Yeah.
All right. Perfect. Sounds good.
All right, well, thank you for the question. And Ian, thanks for hanging with us. I'm sorry your service went down, but I appreciate your answering that. We're going to take a break now and come back at 1:40 Mountain Time with more questions. And then we'll hear from Rob Wills on electrical standards for grid connected equipment.
So welcome back, everybody who has returned from getting your coffee and stretching your legs. So we've got 20 minutes of Q&A before we have our next presentation, really looking at kind of the new and evolving electrical requirements for distributed wind technology or distributed technology. So let's plan to take some questions. First off, remind everybody to mute yourself if you're not talking. If you want to, type questions into the chat, and then because Brent can see them all, he can kind of facilitate, or raise your hands if you want to voice your question, and Brent can kind of field those as we go forward. So Brent, do you see folks who have questions? Oh, and one last thing, try to keep questions kind of focused on broadly speaking. So let's again not dive into technology specific questions. But if you have a question that you think is relevant to multiple people, then let's hit those ones first. And if not, we can dive into more specific ones.
If I can, I have a question. This is Alex Kogan with Hughes Technology.
Okay, Mr. Kogan, what do you have?
I have a question for Ian. I've sent and received back from him, from you, Ian, a couple of emails about our technology. And basically, situation is, we built about 5 prototypes. We have manufacturing capability to produce up to 1,000 units per year. It's 5 to 20 kilowatt units. And right now, because of feedback from, we were applying for CIP program in 2021 and 2020. And because of reviewer feedback that they want to see our system to perform in low wind, we redesigned the system. Now it's performing well in low wind. We run more than 1,000 hours of a CFD simulation of our system. And basically idea is, now I'm confused. I can produce easily, basic on new design, we have drawing and everything. I can produce working system and put this for certification, or I'm kind of little bit confused. We went very long way and we tested the system. By the way, one test we were testing this with Intertech.
Okay.
Yes.
Again, let's get to the question, and if it's really specific to your technology, then I would say let's schedule a time to meet in the next couple of weeks to dive into your technology and where you think it fits into the CIP. If you have a broader question, then happy to answer it.
Okay, for 2021, our application, we were denied, of course, and I was requesting to get reviewer feedback, but I never received it. Is it possible somehow to get reviewer feedback?
Definitely, and the issue that we have is that we cannot start providing reviewer feedback from the 2021 solicitation until the contracts are signed for the ones that are moving forward. And so all of the contracts have been signed with the awardees under 2021. So Kendall Jackson, the contract administrator, should be reaching out to you shortly to set up a time for a feedback into your proposals. So
Sounds good.
Reach out to
Thank you.
Kendall, and just to make sure that it's on her radar screen, if you would. And then I'll also take a note to have her reach out to you to set up a time.
Yes,
And
we
we'll
are
try to do
exchanging
that
email.
really quickly.
We were exchanging email with Kindle
Okay.
during last
Okay.
probably months or so. Okay.
Okay.
Understand.
Great.
And actually, how we can arrange appointment meeting in order to discuss specific of my technology.
Okay. And so let's plan to do both: formal feedback on on the last submission, and then a more general conversation about your technology. I think both of those would be helpful.
Okay, sounds good.
All
Great.
right, thank you, Ian, and thank you, Mr. Kogan. And let's see, I don't have any in the chat, and I don't see any hands. Anyone want to unmute and ask any questions at this point, or type in, or raise, or comment?
Brent, I've got a quickie. How would something like a microgrid system that's designed for a wind turbine application fit if someone was focused, for example, on the battery and other gear, not so much the wind turbine, but could work with the wind turbine? Is that compatible with the CIP?
Rob, we
or would
can't
that
hear
be-
you. Can you speak up?
Yeah.
Oh,
Yeah.
okay.
And Rob, introduce yourself, please, as
Yeah,
well.
see, Robert Wills from Intergrid, and I'll see. If
Oh,
I can
it sounds
mic
like you're
through.
really far away from your microphone.
Okay, I'm going to try a different mic then because I'll be presenting. So just
Okay.
give me a chance
But-
on that.
Okay.
Yeah. Anyway, the
Okay,
question was
but I can.
microgrid.
Yeah, so I can answer that. So Rob's question, for those that couldn't hear, was how would something like a microgrid fit into, or would a microgrid fit into CIP, where we have a defined turbine, but we don't have the battery or the controller or things of that nature, and how would that fit? Historically, so the first question is yes, that does fit. And we have awarded solicitations, proposals around that. Typically, those have gone under as a component improvement. And so you have a defined turbine that is certified or on the path to certification. But what you're looking at is an additional application component to support a new market area. So even though it's a little bit of a stretch, it's similar to a new tower for your certified turbine. And so you would want to articulate, we are going to take this turbine that's already been certified or is already in the market space, and we are going to develop a new component to allow us to use this turbine in a new market space. An example of this is the Berge deployable turbine concept, where he has taken his turbine and has packaged around that a deployable system to be used in kind of off-grid applications. The key would be to, again, demonstrate a market for your microgrid concept and articulate the cost benefit of what you're doing in comparison to what is available out there in that market space. So if you're looking at an isolated microgrid, it might be a diesel engine or something of that nature, and how what you're proposing competes favorably into that alternative market. And then you would articulate the component in innovation that you're planning on doing. And that would be the microgrid controller or the power electronics to allow your turbine to operate in that new application space.
Okay.
But happy to follow up with specifics. Yeah.
So just as a check for the next part, how's my audio now? I've gone just back to the straight computer.
Good.
Okay.
That sounds better, Rob.
That sounds great.
Okay,
Yeah.
good, thank you.
Thank you for that question. And yeah, that's a contemporary question. Any others?
Jim Truslow, CBC Wind Energy.
Hi.
How are you?
Great.
I just have a quick question. The topic area that used to be listed as prototype testing and is now listed as prototype installation and testing. Obviously, what you're saying now is that that topic area, the costs involved would be for the installation of the unit and the testing of the unit. And my question is, on the price participation minimum, does the developer get to count the cost of manufacturing the unit, the prototype that they're testing, as its price participation?
So yes, and Kendall will dive into this on Thursday when she talks about price participation. So feel free to bring this up again with Kendall, because there is a whole packet of information that you can get. I mean, it's on our website that talks about what can be included in price participation within a subcontract. The manufacture of the turbine might not be, but the price of the turbine is. And so if you're supplying a $30,000 turbine, again, you probably define, again, this is more of a question for Kendall, you define what the cost of the turbine is to provide into the project. But the cost of the turbine or tower or what have you can be counted as your price participation.
Oh, that's excellent news. Thank you.
Yeah, good. Yeah, thanks for the question.
And just to be clear, the prototype testing category has always included the installation of the turbine, if you would like that to happen. We just added that here because it could be a little confusing. One of them is manufacture and installation, and then the other one just says testing. And so we added the installation and testing because it can include the installation of the turbine for testing, and typically does. I think going back as far as I can remember, all of the prototype testing has included some cost around the installation of the prototype turbine for testing.
Yes, and we're new to this, but I think that I have read everything from last year, and I think that addition helps clarify those categories of topics.
Okay, great. Thank you.
Awesome. Thank you, Ian. Heather Rhodes Weaver has her hand up.
I do. Can you hear me?
Yeah.
So Ian, I had a question about your comment of multiple applications in the same cycle. I've been involved in some of those, and I think the issue is that the size of the awards is relatively limited. So if a company is trying to innovate multiple components at the same time, that has been a strategy. And are you saying that that's not appropriate? That it's better just to pick one topic and go for it rather than trying to get multiple awards?
Yeah, no, thank you so much for that question, Heather, because it's a little bit confusing. So there are two elements to this. On the front level, if you have a company that wants to submit multiple proposals, please do so. So there is no requirement about not submitting multiple proposals. Now, my comments, at least initially, were more around submitting basically the same proposal to cover the same thing for different topical areas. So a hypothetical example, you have a turbine, and this is hypothetical, but we have had this. We have had one company, or multiple times, but a company submit a proposal for prototype testing, certification, and prototype development. So they've got a turbine and they're kind of tossing in the same proposal, but change the title a little bit and say, our turbine is ready for prototype development So we've got a good design, but we could improve the prototype a little bit more. Or if you want to pay us to test it, we're happy to build one and test it. Or we really think we're okay for certification. So we're going to put in 3 proposals, all basically the same proposal for the same technology, but we're going to put it in 3 ways. That is going to fail writ large because it demonstrates you actually don't know what you're doing and you don't know where your technology is. So much better to say, our technology, we're in a prototype stage, we have a version and we want to put it on tower. We are going to submit for prototype testing, and that's where we are, and that's what we're going to do. Okay, now a company that, and again, we have examples of this, a company that might come in and say, we have got a great product and we want to certify it, and so we're going to submit for certification, but we also know that our tower is too expensive, and so we want to submit a component improvement for the tower, but we want to certify the product that we have, understanding that the tower does not fit within the certification framework. You can have a new tower or multiple towers that can fit under your turbine. That is perfectly acceptable, and we would encourage you to do that. Okay, so you're certifying your turbine, but you're submitting a proposal for the tower. If we fund one of those, or if we fund both of them can move forward. So we would be a little bit worried if you were putting in a certification for a turbine, but then you were putting a new rotor set on that turbine, because you're certifying a unit, but you're proposing to us that you're going to do a whole nother rotor, which would impact the certification of the previous unit. Now, again, if you would like to do that, please go ahead, but you should certainly articulate in both of those proposals why doing one of them isn't going to negatively impact the other one. So we're not very interested in certifying your turbine if in the next breath you're going to put a new rotor on there and you're going to have to recertify the turbine next year. Again, that doesn't seem like a good use of money. But if you could articulate to us that the rotor that you already have on there is great for high wind markets or something of that nature, and so you want to certify that product, but you still want to do innovation going forwards, then please do that. But just articulate to us so that we understand your thinking. The one caveat to this, though, are those programmatic factors that I mentioned as well. And so we are less likely to fund a single company multiple awards if we're tight on funds. And so we want to make sure that we're covering the kind of a broad scope of projects. Now, if a single company puts in 2 fabulous proposals that really have huge impact, we will and we have the resources to fund both of them. We're happy to fund both of them, and we have done that in the past. So companies have received multiple awards at a single time, and then there are a bunch of companies out there that have multiple awards going over consecutive years. So they got an award in 2019, and they got an award in 2020, and so there's a number of companies out there that have both. But if you're putting in multiple proposals, understand that if push comes to shove and you're on the borderline, then those programmatic factors may come in to say, if we're already investing $1 million in one company and there's another company that we haven't invested in but has a very good proposal and the scores are ostensibly the same, that we could use those programmatic factors to fund the company that hasn't gotten an award or is in a new area or has a new technology that seems innovative that hasn't been investigated before. I hope that's answered your question.
I did, yes, thank you. And I did put a couple others in the chat earlier that you'll probably be addressing throughout the week if you didn't see those, but I know you're not allowed to talk specifically about what's coming up, but just a comment that when the guidelines change every year, it makes it challenging to kind of resubmit something that was a good idea that might still be a good idea, but you have to rearrange everything. So just a comment about that.
No, certainly, and understood. So maybe we haven't covered that. You will notice that if you go back over years, the language really doesn't change very much in the awards or in the call for proposals. And that's for exactly that reason, Heather, is we don't want people to have to rewrite proposals that are good proposals. And so in the ones that exist and the ones that have existed for a long time, like the component innovation and the optimization, any changes we make are there hopefully to address questions or issues that have been brought up in the proposal process to help clarify for all of you. And we try to keep things as static as possible for that exact reason. Again, we can't comment on what might come in the future, as you specifically note, but it's certainly our hope that we're not changing things too drastically, because we know it's a huge investment to write proposals.
Excellent, thanks. And Heather, I apologize, I didn't see any previous questions in the chat from you, unless it was in your intro.
That's okay. The other part was just on timing. And again, I know you guys can't say anything about that, but when Ian mentioned about the feedback from last cycle, I just hope the window is big enough to actually get that feedback before it closes again. And then again, the turnaround time from when the RFP comes out till when the deadline of when they're due again. Just know that it's still COVID for some of us, right? Yeah.
Still COVID for all of us. Yes.
Especially
very,
those
very
of
good
us
point.
with kids in school. Yes.
Yeah. It is worth noting that last year, people will note that the timing was moved up, and that was primarily around the transition of the administration. And so there was a unique driver that drove the early release of last year's solicitation.
That's right. Okay, well, thanks for all the questions, and thanks, Ian, for all the answers. Appreciate it. Well, it's 2 o'clock in Denver, and it's 4 o'clock here on the East Coast. And we have one more session for today, and then we'll reconvene tomorrow. This session's on electrical standards for grid-connected wind energy equipment. It's listed as Brent, Summerville, and Robert Wills, but it's mostly Robert Wills. Let me introduce Dr. Rob Wills. He studied electrical engineering in Melbourne, Australia, and then at Dartmouth College. Rob started in the renewable energy industry back in 1982, living off-grid in Vermont. He has been involved in power electronics and controls for wind, solar, fuel cells, and even some marine hydrokinetic technology ever since, including the co-design of the Southwest Wind Power SkyStream inverter, and with his new company, or newish, Intergrid, the development of the IG-25 small wind inverter. Rob represents the wind industry, the National Electrical Code panel, and yeah, welcome to Rob Wills to tell us about electrical standards. I'm gonna try to start it off with some basic intro, and then turn it over to Dr. Wills or Rob. But the electrical standards around grid-connected equipment, wind energy in particular, can be described as a three-legged stool. So the components or even the turbine system must meet the requirements in some electrical standards such as IEEE 1547. And then they must demonstrate that they meet those standards through some type testing by a nationally recognized testing laboratory, NREL, according to standards on testing such as UL 1741. And then the National Electrical Code requires them to be installed per the requirements in the code and with specific articles pertaining to this industry. Another way to look at it is the wind system is installed per the NEC, the National Electrical Code, and Rob will go over the details in Article 694 which apply to wind electric systems, and some other articles that also may apply. And a relatively new requirement is that the whole turbine system shall be listed to these two UL standards, one of them. UL 6142 is the standard for safety. Now, remember, it's electrical safety for small wind turbine systems. Or if you're not small, then you would need to be listed to UL 6141, wind turbines permitting entry of personnel. So this is pretty unique. We know that it's quite a challenge to really nail down a hard definition of small wind versus large wind, but UL's done it, and that can you get inside it or not? So it's pretty creative. The part where the system connects to the electrical grid, the inverter, for instance, must be listed to IEEE 1547 standard for interconnected and interconnection and interoperability of distributed energy resources with associated electric power systems interfaces. That's catchy. And tested to UL 1741, the standard for inverters, converters, controllers, and interconnection system equipment for use with distributed energy resources. And then Rob adds that in some jurisdictions, there's a new requirement, mostly driven by PV, to have a utility communication through a standard protocol. So the inverter also has communication requirements according to IEEE 2030.5, which came out in 2018, the standard for smart energy profile application protocol. So I got to admit, this stuff is a lot for an old mechanical engineer like me, but I am I'm learning about it. And basically in our small industry, someone has to show up and pay attention to these standards and ensure nothing terrible happens, in the standards that will create many problems. So I'm trying to learn and pay attention. All right, Rob, thanks for coming today and helping with this topic.
Okay, you're very welcome, Brent. So first thing to say is a great thank you to Robert Preuss, who's now retired from NREL, who helped write the small wind article in the National Electric Code with me many years ago. And congratulations to Brent, who is now filling Robert's shoes on the NEC. And we have a shift here, and that originally I was representing AWEA, which is now American Clean Power, and Robert Preuss was my alternate. And because we have a more representative body for small wind, distributed wind, Brent is now a full member of NEC representing AWEA. So that's great. It means we have 2 votes on the committee, which often can be very important. So congratulations, Brent. The National Electric Code is a manual covering essentially installation of equipment as it applies to us. But this is the actual language from the scope in Article 90 of the National Electric Code. Installation and removal of electrical conductors, equipment and raceways, and then a lot of other stuff. But it excludes installations under the exclusive control of an electric utility, including generation. So pretty obviously the coal plant at the down in Bow, New Hampshire, or in the Midwest would not be appropriate for National Electric Code. But there is an issue about independent power production, whether it's wind or solar or any other means, may fall under the NEC. Next slide, please. So the National Electric Code is divided into 8 core sections. The first 4 are general, things that are important, like wiring methods, materials, and equipment. And it's important to say the National Electric Code is sort of like the Electrical Olympics. The level of engineering that we experience on these committees is very high, and the amount of money related to a small change could impact an industry dramatically, as Brent alluded to. So, for example, a small change on what wiring methods are allowed or what conduit is allowed or something like that could affect multi-million-dollar industries. So it's a very important and process, and something that's open and generally very fair. The last 4 sections are called special sections. Number 5 is special occupancy. So that would be like installing at a gas station. Number 6 is the one we're related to, special equipment. That's wind and solar and many other things. And then 7 is special conditions, and 8 is communications. So it's important to note that if there's a statement in a section 6, like 694, that, for example, you don't have to ground the metal tail of a wind turbine, that overrides the general section's requirements for grounding in general. Special sections override general sections. Next slide, please. So the requirements for safe installations under equipment have slowly changed over the years, but it's now come to the point where all electrical equipment installed under the National Electric Code must be listed and approved for the application. So this word listing and approval many years ago used to come down to your local electrical inspector. They'd say that, look, that looks good enough. But as technology got more complicated, the national testing labs like Intertech and Underwriters Labs were employed to do very deep testing on equipment and wiring methods and so on, to draw up standards, and they're the UL standards we'll be talking about. And so typically there's a type testing, and the word listing is often stated with a capital L to indicate that a national testing lab has listed the device as being approved for a particular standard. There are options for field labeling. If you have a wind turbine and it's really a unique device, and you want to have it approved for interconnection, then it's possible to have a testing lab come out and evaluate it in the field. And ultimately, everything has to have a label that says that it is certified. So that's all part of the equipment side. On the methods and practices, that falls more into the National Electric Code. Wiring practices, you need disconnect switches so that you can safely service a piece of equipment and know that it's de-energized. In most cases, exposed metal needs to be grounded to protect from electric shock hazards, and wiring has to be of sufficient size and of appropriate insulation to meet the needs. And then there are things like conduit and raceway sizes. Next slide, please. So digging into this, under special use chapters, there are 2 that are most appropriate to wind electric systems. 694 was written about 10 years ago. It was based on the photovoltaic standard, but Robert and I took all the good parts of the photovoltaic part, cleaned it up, sat down with the editors at the National Electric Code. We're pretty happy that there haven't been any really major changes to 694 over that 10 years, whereas PV has a much larger community, but they've had to change and change and change. And so you'll see even in the next edition, the 2023 edition of the National Electric Code, 690 has changed dramatically, 694, minimal change. The other part that's important is Article 705, which is interconnected electric power production. So the language in 705 was originally in the photovoltaic section, and we duplicated it in the wind section, and then duplicated it in energy storage, and realized that was pretty silly. So it was pulled out and put into its own area. And it covers things like if you're connecting to a utility electric power system, you have to have an inverter that's designed to interconnect and has been tested to interconnect per the appropriate standards, and we'll get into that further. It also says where you're allowed to connect, either on the supply side of the utility disconnect or on the load side. And typically with larger turbines, we end up doing what's called a supply side connection, because there are a lot of limitations in 705 as to how much power you can feed back into a normal electrical panel, typically 20% of its rating. Next slide, please. So now, specifically looking at Article 694, you'll note that we didn't call it wind turbine systems, and this was just a nod to the fact that there are some rather obscure systems out there that are not turbines. They might be the vibrating poles, or they might be the electrostatic grids that appeared in Popular Science in 1960, but it's possible that wind systems would not be turbines, and so we broadened the language out, but in the scope you can see we bring up the concept that a wind electric system is typically a wind turbine system. And this relates to one or more wind electric generators and related alternators, generators, inverters, controllers, and so on. And you can see on the left, the scope then moves on to installation, covers the systems, the equipment, requirements for diversion load controllers, also called dump loads, requirements for surge protective devices, and then many other things. Next slide, please. So the National Electric Code is a 3-year cycle. And for this current cycle, we had public input from May to September last year. We had a virtual first draft meeting in January 2021. The report from that meeting came out in mid-2021, and we accepted more public input. And then we recently had the second draft meeting in November 2021 that Brent and I attended. And then the report and the initial voting in committee meetings for that has now been released, and that will become final on the 17th of December. I have to vote on the changes in all the things that our code making panel covers. And then once that approval is reached on all the various changes, it will go to the National Fire Protection Association annual meeting to be voted, and then by March 2022, the new NEC will be released. The effort to write the NEC falls to code-making panels, of which there are about 20, and the process is open and democratic, and it's a lot of work. At times, code-making panel 4, which covers photovoltaics and wind and fuel cells and interconnection, has had more than 600 proposals submitted to it. We often meet for 5 or 6 days when it was in person, and the meetings are held under formal Roberts rules. So membership is very diverse: electrical inspectors, contractors, installers, high-powered IEEE, professors, NEMA, National Electrical Manufacturers Association, manufacturers, utilities, and the electrical organizations, the International Brotherhood of Electrical Workers, National Electric Contractors Association. And there are actually 3 solar associations on the committee representing Solar Energy Industries Association, an ad hoc group of codes and standards working people, and another organization called the Large Solar Energy Association. Next slide, please. So the changes we're seeing in, this should actually read 694, that's a typo. The main job, oh, Brent's going to fix it on the fly, thank you. So the main job that we have on the committee is to make sure that changes don't impact commercial installation. There was a proposal to add an Article 695 or something that would have similar implications to the Article 691 large-scale solar that was added a few years ago. There's a real issue about jurisdiction for megawatt scale wind and for solar, and it was addressed in part by this Article 691. We avoided that because we think what's in 694 now is quite adequate to deal with wind turbines that fall under the National Electric Code, even up into the megawatt scale. A community 1 or 5 megawatt wind turbine is quite possible and could fall under the NEC. But at this point, there don't seem to be any real issues that would need a different article. Large-scale solar is rather different to large-scale wind. If you have 1 or 5 1 megawatt wind turbines, it's not quite the same as putting out a gigawatt of PV. Another one that came in was electromagnetic pulse immunity, saying that we had to design for that. That was voted down pretty much across the board. There were applications or requests to put that into just about every article in the code. There were some voltage protective devices that were proposed that were specific to one manufacturer. That was voted down. And something very controversial that happened over the last few years in solar was the need for rapid shutdown to protect firefighters. We typically don't install wind turbines on roofs, and so the need for rapid shutdown is just not there, and there is a requirement for a shutdown means on a wind turbine anyway, so that one we managed to exclude. And finally, there's been a sort of creeping language inclusion in all the National Electric Code articles to say that installation should be done by qualified persons. And this got added into just about every article, and it was pushed by the IBEW and other installation associations to say that if you're putting in a PV array, then the electrician should be installing the modules and so on. And it's a difficult question to answer, but it was really unnecessary to have that language in every article of the code. And so this language has now been put into Article 90, the introduction to the National Electric Code, in one place, which makes more sense. Yes, people should be qualified. By the way, before I get to the next part, the little comic here is about us keeping our finger in the dike to make sure the changes aren't too dramatic, and that's also a testament and a thank you to Jeroen for all the work that he does in codes and standards, being of Dutch origin.
And
So,
Rob, just FYI, we've only got about 8 minutes left. So.
Okay, so I'll run fast then. Okay, so included are definitions of move to Article 100, marking requirements, in other words, placards and so on, to move to 705. Next slide, please. So changes that cover us generally in the NEC as surge protective devices that we required in the past for wind systems are now required across the board, and an external main disconnect is required on a house. And a really big one is that power control systems in 705 now allow the control system to limit the current of a combined storage renewable energy generation system. In the past, that was a showstopper. And the non-residential voltage limits have been raised from 600 to 1,000 volts. Next one. So there is a scope issue with the National Electric Code. If you're interested in this, feel free to call or talk to me or Brent. But the essence of it is that independent power producers are included in the scope, but utility-owned generation is not included in the scope. And many of us say, well, what's the difference between a 1 megawatt turbine owned by a private entity to one owned by a utility? Next slide. So You can read up on this later, but the National Electric Safety Code covers the utility side. And the main issue there is that it doesn't have any requirements for distributed generation that are appropriate. And so in general, electrical inspectors or even utilities drop back to the NEC, but there is a working group in NESC that is looking at adding appropriate language so that we can finally resolve this issue. Next slide, please. So that brings us to IEEE 1547. When you interconnect an inverter-based system to the electric grid, things have changed. IEEE 1547 is the standard for interconnection with the electric grid, as you can see on the left. And in 2003, the utilities said, we don't want you to interfere. If something goes wrong, turn off, stay off for 5 minutes. Now, with the level of penetration in California and Hawaii, renewable energy is essential, and it's important that there is this ride-through capability. So grid interaction went from simple voltage and frequency trips where we needed to turn off if something went wrong to where we had to do ride-through. And now we also have to do things like modulating reactive power in response to voltage and frequency. Also, as Brent mentioned, there are now communications requirements that are enforced by some states, and there are 3 flavors available: SunSpec, IEEE 2030.5 or DMP3. In general, the industry seems to be moving towards the IEEE standard. And the impact of these changes is dramatic. We tested an inverter to the original IEEE 1547 many years ago. It took about 8 hours of testing. I think we finished it with an NRTL bill of $12,000. The next rev of the standard, which came out, took about 40 hours. And now we're looking at roughly 400 hours of automated testing to approve 1547.1, the testing requirements that were brought up in late 2020. Next slide, please. The adoption of 1547-2018 and the Supplement B requirement. Supplement B is language in the 1741 inverter standard that says you have to comply with 1547 and you have to comply with 1547.1, which is how to test. And you can see that a lot of really key jurisdictions are going to be requiring this Supplement B by early 2022. So we're all working very hard to achieve those certifications. Next slide, please. So briefly, Supplement SA remains in the 1741 requirements. So that was the previous one, but anyone testing to Supplement A now is really looking at a dead end, and Supplement B is going to be the requirement. Next slide, please. So the rest of the story is that it's all very well to have a certified inverter and electronics, but the whole turbine now has to be certified. So in the NEC, it says wind turbine electrical systems must be listed or field evaluated per 694. And as Brent said, there are 2 standards, one where you can enter the turbine and one where not. And curiously, personnel access was really the only inherent specific difference. Next slide, please. So it's possible to list a wind turbine as a system, and that involves a pretty comprehensive safety evaluation for the electrical components in the system and the overall system to make sure, for example, that you can't overspeed and throw blades. But it does not include mechanical evaluation. That's a separate thing. It also involves a review of the manufacturing QA processes. And we highly recommend, if you're looking at certification, that you engage a certification body, a nationally recognized testing lab, to help with the design phase, because otherwise you'll find you'll have to go back and do it again. And field labeling, as we said before, is available. In either case, a very, very complete design documentation is required, drawings, schematics, bills of materials. They'll go through everything with a fine-tooth comb and make sure that it meets all their safety standards. Next slide, please. And that's it. So thank you from Rob and Brent, and we'll entertain some questions with 1 minute to go.
Yeah, thank you, Rob, for staying on top of all this. And I know you're deeply involved because you developed that new inverter and you're taking it through all this madness. So firsthand knowledge. We did have a question about sharing the PowerPoints. I know we will post the recording, but I don't know if we have any precedence of sharing the PDFs of the slides. I think
Yeah.
it's the recording.
Brent, we will share the PDF of the slides. You can find, if you go onto the current CIP website, you can find the slides from last year that are not exact but are close. And so I'd encourage you to do that. In the meantime, given the holidays, it probably won't happen until early January, but we will get the slides and the recordings up as soon as we can.
Thank you, Ian.
And again, those will be on the NREL CIP website.
Great. Okay, 46 people remain. Not bad. Any questions on today or on electrical safety standards? Electrical standards? Great.
Time for a cup of tea.
Yeah. Okay.
Great.
Thank you. And from my viewpoint, anyone feel free to just email me and I'll do what I can. So in the codes and standards area, both Brent and I essentially provide pro bono support for a lot of companies to help out. So happy to do that.
Great. Thank you for that, Rob, and thank you for talking today.